link. Today I will share with you a topic on signal transformations. Signal transformation consists of amplitude scaling, time shifting, time scaling, multiple transformation, time reversal, addition, subtraction, multiplication, divisions, and differential and integrations. But today, I will just share with you or only focus on the amplitude scaling, time shifting, time scaling, and multiple transformations. The learning outcomes are at the end of this topic, students will be able to solve amplitude scaling, time shifting, time scaling, and multiple transformations using mathematical and graphical methods.
First signal transformation is the amplitude scaling. Amplitude scaling is the process of changing the magnitude of the signal that can be defined as yt equal to axt. Okay, so A is a scaling factor. If the A is less than 1, the signal is attenuated. Then for A is more than 1, signal is amplified. Here is the simple block diagram where X is the input, A is the amplitude scaling, and Y is the output. So here mentioned that if A less than 1, signal is attenuated. How the signal is attenuated looks like? Okay, for example, if you have the signal xt, looks like this, a sinusoidal wave. Okay, and the A is equal to 1. The scaling factor is equal to 1. So now when A is less than 1, signal is attenuated. So it means that A, for example, equal to 0.5. So the signal is reduced from 1 to 0.5. And then for A more than 1, for example, 1.5, okay, and then the signal is amplified from 1 to 1.5.
Second is the time shifting. Time shifting is a process of moving a signal along the time axis, and it can define as yt equal to x t minus t naught. So this is the shifting part. T naught is represent the shift in time. So if let's say if t naught more than 0, the signal is right shifted, or we so-called delay. And if t naught is less than 0, signal is left shifted, or we call it as the advance. So this can be illustrated in the simple block diagram, like this is the input, time delay by t naught. So the equation will be x t minus t naught. So in case there is the advance by t naught, so yt is equal to x t plus t naught. Now let me show you the example of time shifting. So this example is to show you how to get the new location of t axis after time shift. So this is the original signals, the xt. The signal is from -1 to 2. Okay, so the first question is y1t equal to xt minus 3. So this is a shifting. Okay, so this xt minus 3 also equivalent to xt minus 3. So the shift is the positive. So it's a right shifted 3 units. Okay, right shifted by 3 units. So the whole graph here of the xt will be shifted to the right. Okay, starting from -1. So now you look at the arrow here. For -1 to 0, 0 to 1, 1 to 2. So this is 3 units to the right. Okay, so the new locations of the t-axis is at 2 to 5. Okay, now for the second question, y2t equal to x t plus 4. Okay, if t plus 4, this means that it's x equivalent to xt minus 4. Because the original equation is t minus t naught, right? So the t naught here is -4. So this means it's left shifted by 4 units. Okay, 4 is 4 units to the left. So you calculate from -1. So you 1, 2, 3, 4. Okay, so you move the from -1 to the new location is -5. So you should shift the whole graph to the left 4 units. So this is the new location of the signals. If you are worried you might shift the graph wrongly, here is another method I will teach you. Just find the lower bound and upper bound. Okay, for example, from these signals, xt from -1 to 2. So after applying the time shifting xt minus 3, okay, this means that the shift 3 units to the right. So let's find the lower bound. So t minus 3. Okay, this is from the question, t minus 3. T new 1 here means that the new location of the t. Okay, minus 3 is from the questions, equal to TO1. What is the O locations? The O location is, this is new location, right? So the O location is -1. So new location is T new location equal to -1. This is the O location, -1 plus 3. -1 plus 3, that will be 2. Then this is the new location. So for the lower bound. So for the upper bound, so t minus 3 equal to 2. Okay, equal to 2. So the upper bound, so t equal to 2 plus 3. Okay, 2 plus 3. Move the 3 to the right. So 2 plus 3 equal to 5. So this 5 will be the upper bound. Okay, let's look at another example. X t plus 4. T plus 4, this means that is x t minus -4. So this negative means is the left shifted 4 units. Okay, left shifted 4 units. So again from the original, so t plus 4. Okay, t plus 4 is from the question. So t plus 4 equal to O value is -1. So it's -1. Bring the 4 to the right, so -1 minus 4, so you get -5. So this is the new locations for the lower bound. For the upper bound, so t plus 4 equal to 2. Okay, equal to 2. So 2 minus 4 equal to -2. So this -2 will be the latest upper bound locations. Alright, do you get it? Next is the time scaling. Time scaling can be defined as yt equal to x beta t. So this beta, the beta here is the constant, or we call it as a scaling factor. So if a modulus beta more than 1, it is the time compressed. And when modulus beta less than 1, it is time expanded. Let me show you an example of the time scaling. So given xt, the signal is from -1 to 1. Now if the question is x t over 2, so this is a scaling, t over 2 is a time scaling. So we need to find what is the new lower bound and upper bound. Okay, we can use the formula like t over 2. T over 2 is from the questions. Okay, t over 2, because we need to find the t over 2 here. The scaling factor, scaling is t over 2. The beta is 1 over 2. Okay, because the question t over 2, so we put t over 2 here, and then equal to all location. All location here, we want to find the lower bound. So the all location is -1. So we put here -1. So the new location of the lower outbound is -1 times with 2. So you get -2. Then what about upper bound? Upper bound means, okay, so normally we, left hand side we name it as a lower bound, right hand side we name it as an upper bound. So just now we find the lower bound. Now upper bound is t over 2 again, equal to what is the all locations of the upper bound? Okay, from the all location means that the original signal, that is 1. So what is the new location? So the t here is 2 times 1, so you get 2. Okay, so the new location is from -2 to 2. Okay, another example, if I have the question is x to t. So now I need to find what is the new lower bound and outbound for the question of x to t. So again, for the lower bound, the question is 2t, right? So 2t equal to the all the original all locations. The all location is -1. So the new location is all location is -1. So -1 times with 2. So you get, this is time. So you go to the right hand side is divide. So -1/2. And then upper bound, what's the upper bound locations? So it's 2t equal to the all location is 1. So when you want to get the t here is 1/2. So it's here from -1/2 to +1/2. Do you get it? Next is multiple transformations. Multiple transformations means applying more than one operation to a signal, one after another. The common signal transformations normally time shifting, time scaling, amplitude scaling, and time reversal. So let's look at this one. The signal xt equal to ax t minus t naught over a. Okay, so how to solve these multiple transformations? It can be done via the step of xt, okay, the common signal xt. Okay, then first you process with the amplitude scaling first. So axt is the amplitude scaling. Next is axt over a. This part t over a is time scaling. Okay, and then next is axt minus t naught over a. So this part is a time shifting. So if you follow this sequence, that will be the amplitude scaling, time scaling, and time shifting. You also can solve via the sequence of amplitude scaling, time shifting, then time scaling. So if you do the time shifting first, that will be ax t minus t naught. So this part is a shifting. Then followed by time scaling. So time scaling is t over a minus t naught. So minus t naught actually is from the time shifting. So you take the latest answer from the time shifting and do the time scaling. And then please take note that these two output, okay, ax t minus t naught over a, if you compare with t over a minus t naught, these two is not the same. It's not equivalent, okay? There are three methods in solving the multiple transformations. So the first method is through the amplitude scaling, time shifting, then time scaling. Okay, the sequence is like this. So if you have the signal in this form, okay, axt minus t naught over a, you got to change it to this form. Okay, axt over a minus t naught over a. Okay, if you want to solve the time shifting first. Okay, so in this one, the sequence, so you start with the amplitude scaling. So amplitude scaling by a, so you have axt. Then you do the time shifting. Shifting is t naught. Okay, time shifting is t naught over a. Then time scaling. So t over a, this part is 1 over a. So time scaling by 1 over a. Now we use the first method to solve these multiple transformations. Given a signal gt equal to -2 gt plus 2 over 4. The signal gt is this one, okay, from -half to half. So first of all, we solve using the amplitude scaling first. The amplitude scaling is -2. Okay, so your original signal is 1. From -half to half, you have 1. So you time with -2, so you get -2. The location is still the same, from -half to half of the t. So this is -2 ut. Next, we do the time shifting. So time shifting here, to do the time shifting, we must convert this form of the gt to this format. So you have t over 4 plus 2 over 4. Okay, we separate into this one. t over 4, okay, plus 2 over 4. So this part is the shifting part. So 2 over 4 also equivalent to 1 over 2. Okay, so time shifting is t plus 1 over 2. This means that what? T plus 1 over 2 means we shift the half to the left. The whole graph here, you shift to the left half unit. So initially that is from negative half to half. So you shift half unit to the left. That will be from negative 1 to 0. Okay, so this is the time shifting. Next is the time scaling. So time scaling is this part, t over 4. Okay, t over 4. So now we need to find what is the lower bound and what is the upper bound. So to find the lower bound, so just now the time scaling is t over 4, right? So t over 4 equal to negative 1. So how to find negative 1? So that is the last, or we say that is the latest signal, okay, from the last operations. So last operation is the time scale shifting. So this is the answer from the time shifting. So it's negative 1. So we just take it from here, negative 1. T over 4 is the operation of the time scaling. Okay, we take t over 4. So t over 4 equal to negative 1. So how to get t? So t, you move the 4 to multiply with negative 1, so you got negative 4. It's the same to find the upper bound. So you have t over 4 equal to 0. Okay, this value is 0. So t also equal to 0. So the last answer is from negative 4 to 0 after this operation. Second method is you have to write the transformation of the signal into this form. Ax t minus t naught over a. So in this form, we follow the sequence of amplitude scaling, where axt is amplitude scaling, the a here, and then axt over a, this one is the time scaling. Okay, this part is the time scaling. Okay, it is a time scaling by 1 over a, and lastly is the time shifting, t minus t naught over a. So this t naught is a time shifting. Now, let's use method 2 to solve these questions. So it's the same question from previous. Okay, the gt is negative 2 gt plus 2 over 4. So the original signal is this one. Again, we use the amplitude scaling, in which this is negative 2, the amplitude here. The time reversal is a negative. 2 is the scaling, amplitude scaling, so it's negative 2. Okay, the amplitude is negative 2. So we finish the amplitude scaling. Then next is time scaling. So time scaling, we need to find the lower bound and the upper bound. Okay, so let's look at the time scaling is t over 4. Okay, t over 4. So t over 4, we put t over 4 is the time scaling, and then the latest answer of the lower bound is negative half. Okay, so t is equal to, you move the 4 to the right, so you get negative 2. Then you find the upper bound, so t over 4 equal to positive half, this is this value. Then t equal to 2. So the lower bound is negative 2, upper bound is positive 2. So your signal of the time scaling is this one. Then lastly is the time shifting. So time shifting is t plus 2. Okay, t plus 2. Okay, from negative 2 to 2, you move the whole graph 2 unit to the left. Okay, 2 unit to the left, this means negative 2, then negative 3, negative 4. So it's 2 unit to the left. So this is the answer for the final answer. Okay, from negative 4 to 0. So although you're using doesn't matter you use method 1 or method 2, so you will get the same answer. Just that the format. Okay, the format you use method 2 is this format, different from the format you use for the format of this one, of the signal you use for method 1. Now in this example, we use the method 3 to do the multiple transformations. So the same questions, which is negative 2g t or plus 2 over 4. So first of all, we do the amplitude scaling first. Okay, so this negative 2 is the amplitude. And then you multiply with this original signal, which is amplitude is 1. So negative 2 multiplied with 1, you get negative 2. Okay, the range is from negative half to half, it remains the same. Okay, next is we do this one, the time scaling and time shifting together. Okay, t plus 2 over 4. So we can do here is t plus 2, we need to find lower bound and upper bound. So t plus 2 over 4, okay, the lower bound, we take the latest value, which is negative half. And then t equal to, you bring the 4 to the right hand side. Okay, so you got negative half multiplied with 4 minus 2. So you move the 2 here to the right hand side, you negative 2. So this one, the t equal to negative 2 minus negative 2. Negative 2 minus 2 equal to negative 4. And then this equivalent to the latest value of the lower bound. So for upper bound, also the same, t plus 2 over 4 equal to the latest value here. So it's positive 2. So t equivalent to the half multiplied with the 4 minus with the 2 here. So you got 2 minus 2 is 0. So the latest value is 0. Okay, so the answer quite straightforward if you use the method 3 as compared to the method 1 and method 2. Thank you for watching. If you like my video, please hit the like button at the YouTube video. Thank you.